Good morning, everyone. My name is Mohammad Norouzifar. I'm a KTP Associate with the University of Dundee and Rock Solid Processing Limited. Today, I'm going to share the story of our project, integrating CarbonLite IBAA into sustainable concrete in Scotland. This is about turning a waste byproduct into a valuable resource for construction, supporting Scotland's circular economy, and helping reduce carbon. Little about me. I hold two master's degrees. One is civil engineering and structure, and one is structural engineering and concrete materials from Dundee. Over the past 10 years, I built experience in concrete durability, repair mortars, and sustainable aggregates. This combination of academic training and hands-on research experience made me a strong fit for this project, for this KTP project, which requires both technical expertise and the ability to translate into real-world applications. This KTP brings together two complementary partners. Rock Solid Processing Limited are pioneers in metal recovery in the UK and have also developed expertise in producing IBAA as a secondary aggregate. The University of Dundee provides deep expertise in concrete durability and sustainable construction, with advanced facilities for testing and validation. And the knowledge transfer partnership connects these strengths. My role is to act as the bridge, transferring knowledge between academic and industry to make sure this innovation has real commercial impact. Why this project matters? The concrete industry in the UK relies heavily on natural aggregates, sand and stone, which creates environmental pressure and depletes resources. Meanwhile, energy from waste plants generate large volume of bottom ash every year. At present, much of this ash is underused and it represents a lost opportunity. Our question was simple. Can we process this ash and turn it into a safe, valuable aggregate for concrete? If we can, it reduces landfill, saves natural resources, and lowers the carbon footprint of construction. This diagram shows the journey. Municipal waste goes into an energy from waste plant, where energy is produced, but also bottom ash. Ash is then processed, metal are removed, the material is refined and graded into aggregate sizes. And the result is CarbonLite IBAA, a secondary aggregate ready to be used in concrete. So the story is really one of transformation, from waste to resource. Our project has four main goals. First, we test and validate the properties of IBAA in the lab. Second, we demonstrate those findings in real-world trials with industry partners. Third, we transfer that knowledge by creating guidelines, standard procedures, and training for industry. And finally, we build confidence so that IBAA can be adopted more widely across Scotland. So the project is not just about research, it's about ensuring practical commercial impact. This timeline shows what we've achieved so far. We started with a market survey of 29 Scottish companies, and about half of them said they were open to trying IBAA. We then characterized IBAA from 4 energy from waste or EFW plants across Scotland, looking at its physical and chemical properties in the lab, and then we tested mixes and optimized designs for strength and workability. We've carried out durability assessments, carbonation, freeze-thaw, sulfate attack, and alkali silica reaction, and we've delivered field trial with Breton and inverted precast, producing real blocks and lintels with IBAA. So we've already moved from concept to lab to practical demonstration. Knowledge transfer is the heart of this project. For example, when we first started, our mixes showed inconsistencies and high water absorption. We worked with industry partners to find practical solutions like retesting aggregates and adopting pre-soaking methods. We documented these solutions in guidelines and stated of the purposes and provided training for technical staff and plant operators. And we shared results through newsletters, Institute of Concrete Technology or ICT events, and trade publications, ensuring the knowledge didn't just stay in the lab, but reach industry. So how does concrete with CarbonLite IBAA perform? At around 20% replacement, it behaves very much like normal concrete in terms of workability and strength. And one of the most exciting findings is the CarbonLite IBAA concretes absorb more carbon dioxide, so they act as a carbon sink. It has been optimized for multiple applications, including ready-mix, precast elements, blocks, pavers, and lintels. Right now, its best fit is in non-structural applications where it has already shown commercial viability. We've also proven that IBA works outside the lab. At Braydon, we've successfully produced hard-boiled Lego blocks using IBA concrete. At Innovator Precast, we made lintels and demonstrated consistent quality and performance. And both trials showed that mixes were stable and scalable from the laboratory to full industrial production. These real-world demonstrations are building trust with industry partners and showing that CarbonLite IBAA is not just a research material, it's ready for practical use. What we learned, of course, there have been challenges. Our early mixes failed due to inconsistency and water absorption. By retesting the aggregates, we found more accurate values, which improved our understanding of the material. We then introduced pre-soaking and mixing hole techniques to stabilize performance. And the key lesson is that collaboration and systematic problem solving are essential. It shows how academic research and industry know-how can come together to overcome technical barriers. So what's next? We are completing long-term durability tests, free-down cycles, sulfate resistance, and alkali silica reaction. We are expanding field trials with more partners across Scotland to strengthen confidence. And we will pursue BSEN certification, which is crucial for wider adoption. And we are developing a marketing and adoption strategy to support UK-wide implementation. These steps will take CarbonLite IBAA from trials to market reality. To conclude, CarbonLite IBAA is a clear example of turning waste into resource. We've shown that this material can perform well in concrete, reduce demand for natural aggregates, and actively absorb carbon dioxide. This project directly supports Scotland's circular economy and carbon reduction targets, and it's also a strong demonstration of how knowledge transfer between academic and industry can deliver real-world sustainability innovation. Thank you much for your attention, and I'd be very happy to take any questions.